Okay, hello everyone. Let's see exercise number 15. So, Ernie and Bernie wanted to determine the distance of two lonely oak trees, but there was no way to measure their distance directly. So, let me draw it right away. So here's a tree, and then there is another tree, like here. And this is the B tree, and they wanted to measure this distance, but there were no way to measure their distance directly. So therefore they performed the following field measurements. Getting started, they marked out a point at which the angle subtended by the rays to the trees was a right angle. It means that they stood somewhere like here, so that if you take the angle, check the angle from here to A and to B, then it's a right angle. You understand? Okay, so that's where they stood first both of them. And then this was a P point. Actually, this was point P. Starting from this point P, Ernie was walking 100 meters along the line connecting one of the trees and the point P. So what does this mean? That this is the line connecting point P and one of the trees, and Ernie kept walking actually this direction 100 meters. This is 100 meters. Okay, in the opposite direction with respect to the tree. So he started walking not this way, getting closer to the tree, but getting further away from it. He arrived at a point, this is the point, where the angle subtended by the rays to the trees was 40 degrees. It means that from this point, this line, the distance of the tree, it was 40 degrees. Okay, so that's where he went. Okay, as for Bernie, so that was Ernie. Bernie was also walking 100 meters from P along the line connecting the other tree with the point P in the opposite direction with respect to that tree. So Bernie was walking this way 100 meters again. This was also 100 meters. And then he got a point where the angle subtended by the rays to the trees was 37 degrees. So here the degree was 37 degrees. The angle was 37 degrees. So the question is, after this, first we have to sketch a map based on the above information, indicating also the data. We have just done this. Okay, this is the map. And then we have to calculate the distance of the two trees. So the question what we are looking for is AB. AB is how long. So this is, what is this distance? Okay, and if we do it another way, for example, we call it D, then how long is D? But actually we can just use this. It's no problem. All right. So what we know is that, first of all, if this is a right angle, okay, I'll write that down. Before all this, we have to give a name to these points, okay, so that we can refer to them. Let's say this point, okay, so this point is, for example, C, and this point is D. Okay, so what we know is that let's say APB angle is 90 degrees. That's what we know. Okay, what is APB angle? Is this one, APB. So this angle is 90 degrees. That's what we know from the text. It also it also follows that this is a right angle as well, and this is a right angle as well. Okay, because it cuts the 180 degrees into two, this angle. So it means that the CPA angle, sorry, not I wanted to write angle is 90 degrees as well, and the DPB angle is how much? Is also 90 degrees. Now what we know one, if you change, if I consider only the ACP triangle, okay, what do I know? I know one of the side, and I know the angle, one angle, and I know that this is a right triangle, so it has a right angle. So now if I open the book that I have on the trigonometry, or I don't know how to say that, then actually what I can do, I can calculate also the other sides of this triangle. Because, for example, if I have a right angle somewhere in the triangle, that it means that this is the right angle, then A over B, the two smaller sides, the fraction of the two smaller sides, will be the tangent of this angle. So let me write this. Tangent of this 40 degrees is equal to how much? What is equal to AP, this one, this line, over this line, which is CP. So, but I'm actually looking for AP. I want to calculate first this line, okay? So AP is how much? AP is tangent 40 degrees times CP, which is tangent 40 degrees. Let's check. So 40 degrees, and I'm in degrees. You have to change the mode in the calculator, because if you use radian radius, then it's totally different. So it's degree mode, and 40 degrees, the tangent of it is 0.83, and 839, and times what? The CP is 100, because I know it from the text. So times 100 is equal to 83.91 approximately. Okay, so this is AP. I got AP. I underline that. Alright, so now in the similar way I want to calculate PB. Okay, so what do? I do exactly the same. So PB, sorry, I'm now considering another triangle, the PBD triangle. Okay, I do exactly the same. I know that it's a right triangle, I know one angle and the one side, so tangent 39 degrees is equal to PB over PD, which follows that PB is equal to tangent 37 degrees times PD. Now 37 degrees tangent is 0.75 times 100 is equal to 75, around 75.36, or comma in Hungarian. It's different. All right, so PB is 75.36. Okay, so what do I know now? I know in this triangle, I know this side. So this side I know, and I know this side, and I'm looking for this side. But I know that this triangle is it has a right angle. So how can I calculate the longer side then? With the Pythagoras theorem, right? Okay, so with the Pythagoras theorem, I now change colors just to make things a bit more colorful. Pythagoras, I don't know how to write in English anyway, theorem. It says that AB squared is equal to AP squared plus BB squared. Okay, and now what I have to do is I just have to write this in. So 83.91 squared plus 75.36 squared is equal to 12,720. So AB is square root of this number. Okay, 12,720 around, so it's not it's an approximate data, but we can only use this. And then if I take the square root of this, it's around 113. So the question is was how much is the distance between the trees, and the answer is 113 meters. And this is the end of the task.